when we talk about the physical properties of ionic compound, then we can start to think about one very typical example that we encounter daily life, well, which is sodium chloride. Sodium chloride has a very high melting point and boiling point, and definitely, if you try to grab a piece of a grain of sodium chloride, it's extremely hard for you to break it apart. So they are very hard, but eventually, if you try to twist the structure, then it will break quite easily. So physical properties of ionic compound typically is a high melting point and boiling point. As well, they are solid state at room temperature and pressure. So why is it so? Okay, so try to look at this diagram. Okay, well, when I have a cation at the center, okay, usually it can attract several anions. Okay, and not only that, each anions can continue to attract cations nearby. Okay, and then the cations will attract more anions. Okay, and eventually it forms an infinite huge structure. Okay, so this infinite hill structure is very, very well structured and well organized, and it's very, very hard for you to break it apart by simply picking a single cation or a single anion out of this structure. So for uh, these cation and anions, okay, they pack so close with each other. That's why they are always in solid state. And when you try to give it a hammer, okay, that means you try to press it or you hammer it, okay. If you even try to change its structure, it's extremely hard, okay. That's why we said one of the very important property that ionic compound is hard, okay. And another very important property for ionic compound is twist of the structure. If we try to give a twist on the structure, okay, if you try to twist it, okay, think about it. If I twist this layer, the upper layer of the ions for one unit, okay, I twist to, okay, and the two layers will have the positive charge and positive charge, or negative charge and negative charge. That means same charge they will encounter with each other. Okay, well, as we all know that if both of them are same charge, then they will start to have repulsion. Okay, so repulsion happens here. Okay, and due to this repulsion, eventually it will break the structure apart. That's why we can say this ionic compound, they are hard, but they are very brittle. Brittle in terms of it will break the structure when you try to uh, twist the structure. So this is what we call hard and brittle, the property of ionic compound. On the other hand, on the other hand, other physical properties of ionic compound, okay, ionic compound, most of them, quite a lot of them, I will say, quite a lot of them are soluble in water, but not soluble in organic solvent, okay, like heptane, chloroform, okay. Well, you don't have to worry about the name of these organic solvent, but you just remember, okay, they are not very soluble in organic solvent. Some more physical properties, okay, say they can conduct electricity in molten state or aqueous state. Actually, this is very easy to understand and common. Okay, and because when in the ionic compound is in molten state or aqueous state, the ions become mobile, then they can attract towards different terminals of the power supply. Okay, well, but because of this, you're breaking the ionic compound apart. That's why we call this type of substance electrolytes. Electro means using electricity. Light means break down. So that means using electricity can break down this substance. So let's look at the following simulation and hope that you can understand more. So this is an ionic compound. So they pack quite closely with each other. Now I try to give two terminals. One is positive and one is negative on the two sides. Okay, well, according to the electrostatic force, positive charge can definitely attract the negative ions, and on the other hand, the negative terminal can attract the positive ions. But when you but due to the attraction, strong attraction force between the cations and anions, okay, between each of them, so it's very hard for you to break this structure by simply using two terminals right here. Okay, so what can we do is we try to heat them up until it become a molten state. Okay, if you heat it up, it become a molten state, then the ions become more further apart, so it's easier to attract towards the terminals. Or on the other hand, the attraction force between the cations and anions in the molten state is weaker than normal. Okay, not only in a molten state, but also in aqueous states. Aqueous state that means using water to separate the cations and anions apart. Okay, because of these reasons, then the cations and anions can move a little bit more easily. Okay, that's why they can attract towards the negative terminal or positive terminal. Okay, but you notice that the cations and anions, when they move towards a positive terminal or negative terminal, okay, then the original structure is completely broken. So that's why we call this ionic compound in molten state or aqueous state. This is electrolytes. They are the electrolytes. So these are the common physical properties of ionic compound. Okay, just to recap, they usually have high melting point and boiling point. Okay, they can conduct electricity in molten state and aqueous states only, but not in room temperature. Okay, and uh, they can most quite a lot of them are soluble in water. So according to these few physical properties, then we can understand that uh, we can identify ionic compound out of other out of other structures. So hope that this video can help you.